Today we're going to talk about quadratic functions, which almost every time we ask you about quadratic functions, we ask you what do they all have in common. They have a squared, an x squared, a y squared, whatever you have for your variable. That gives you a parabola. So we're going to talk about the old-fashioned way to graph a parabola and then how to do it the more efficient way. It says to graph each function, all of these y equals x squared, y equals 2x squared, and y equals negative 1/2 x squared, all in the same coordinate system. So if we look at these, prior to today, I would probably think most of us would think, well, we need an xy table. Because that's what we need in order to graph. We need all of these points. So if I look at y equals x squared, I'm going to make an xy table. And we pick a negative one, so maybe we'll do, I don't know, let's say -2, -1, 0, 1, and 2. So you can really get a good pattern of what's happening in a parabola. You do need negatives and you need positives because we're going to notice some similarities or what happens in the shape of a parabola. So if I put -2, I'm putting it in for the x value. So I'm looking at y equals -2. Notice that's quantity squared. -2 is x, so we're squaring x. So -2 times -2 is a +4. Then I put in -1. -1 quantity squared would be 1. 0 squared would be 0. 1 squared would be 1. And 2 squared would be 4. So we can graph that. -2, +4. -1, 1, 0, 0, 1, 1, and 2, 4. It should have this pattern where these are the same around what's called your vertex, because a parabola is symmetric. That means I should be able to fold it over on top of each other and it would land on each side. Each side would land on the other.